What we're doing today is a end-to-end system-level test. So we're bringing together all the components that we have developed under the IRIS precursor program, and we are flight testing them in the relevant environment.
Inmarsat is the prime contractor in the IRIS program, contracted by the European Space Agency, basically to now operationalize IRIS, which is a secure data link for air traffic control purposes. Inmarsat has contracted the Dutch aviation research aircraft to run test flights to validate the IRIS avionics boxes that have now been developed. Inmarsat runs this as a prime and has therefore taken the lead role to coordinate these flights. But we're helped, of course, in these flights by the avionics producers as well as the European Space Agency itself. IRIS is the implementation through SATCOM of a new air traffic control system for Europe that will make Europe much more efficient in the way it uses its airspace and therefore enables growth. IRIS is a European project. It's very much driven by Europe because Europe has the densest airspace in the world, so the need to do something about the use of the airspace is really great here. But actually Europe with that is leading the world and is setting a new standard that we think will be adopted by other countries, other areas in the world, and we hope it will become a world standard eventually.
What IRIS really does, it makes modifications to the avionics, makes modifications to the SATCOM systems, and makes modifications to the ground infrastructure to enable these. So what we're doing basically is ensuring that the CPDLC communications can go over the satellite network.
There's in many places single frequencies and too many airplanes speaking on the same frequency. It's a no-go. So this technology enables what we call data link communications, which is basically text messages between the aircraft cockpit and at ATC. And this is the technology we believe will support the way planes will fly in the future.
What we want to ensure is that the messages being sent from the ATC center to the pilot's controller display are meeting the performance requirements required by ICAO and IATA for congested or continental airspace. So we're looking at a very specific time, reliability, accuracy to ensure that messages flow seamlessly. There's always challenges, especially when it comes to aviation. Aviation is a very dynamic industry, but when you want to make changes to anything on the inside of an aircraft, we have to ensure that safety comes first. Everything we've done, we've ensured that the safety of flight, safety of passengers eventually comes foremost. We're trying to implement a system whereby air traffic can really maximize the use of the airways. So for citizens, we are definitely going to be looking at shorter delays and less cancellations. There is going to be lower CO2 emissions as well. You know, there's a lot of benefits that come. Not all tangible immediately, but there will be a lot of benefits.
The benefits of IRIS are generally to, first of all, improve fuel consumption for aircraft, increase capacity of the system, fly more direct routes, passengers will have less delays. It's a necessary technology in order for aviation to have a sustainable growth. We're busy working and designing on the future system, which is called the full operational capability, and that will be the SATCOM's answer, or the satellite answer to the future communication infrastructure, where SATCOM will work alongside terrestrial technologies in this future communication infrastructure for aviation.